Good day, learners. Welcome to Technical Sciences lesson. My name is Zamisile Mdima. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. So today we are taking a final look to forces, and we are ending it by looking at resolution of components. Okay, we're going to combine it with the revision of the entire chapter so that we get a feel of what can we be asked in the past question papers, and then looking forward to this lesson with you guys. Okay, so our main focus today is going to be resolution of forces into components. So firstly, we're going to be looking at resolving a force into components using scale drawing. Also, we're going to be resolving forces into components using calculations. And then we take a look at the past question papers by doing a revision of the entire forces chapter. Okay, let's get into it. And then prior knowledge, what should we be knowing by now? We should be knowing what a resultant force is a single vector or a single force that has the same effect as all the other vectors that are acting together in that particular object. Okay, so what do we need to pay attention on? Okay, we need to be able by now to accurately draw a vector using an appropriate scale. So we should know how to use a scale. Okay, lastly, we should be able to draw vectors in a Cartesian plane coordinate system, in a compass direction, or using bearing. So whichever that is given to us, we should be able to find the direction of these vectors. Okay, so let's look at the first one, where we are resolving a force into its component by using the scale drawing. Let's look at the first problem. It's saying using accurate scale drawing, resolve the following force into vertical and horizontal components. Okay, so in this case, what you should be taking note of is that of the force that is provided to you. What does that mean? It needs to be drawn to scale so that whatever measurements or whatever forces you come up with that are not given to you, you are able to get the correct measurements. Okay, so we're given 30 newtons that is acting in the northeasterly direction. So now, because 30 newtons is too big, this vector is very big to be drawn in an exercise book, so you're going to be required to do what? To use a scale, so that at least we draw a smaller version of this 30 newton vector. Okay, and it's acting at an angle of 30 degrees to the horizontal. Okay, so how do we then approach this? We approach this by saying, okay, let's use an appropriate scale. So let's use a scale of 1 centimeter is equivalent to 10 newtons. Okay, so remember what we said. We need to work out the magnitude now of the line that is representing this vector. Okay, we are given 30 newtons. Thereby, we want to find out how much of this 30 newtons are we going to write down, because the scale is helping us to enlarge or to reduce. So in this case, we cross multiply, but before we even do, this unit will therefore cancel this other unit over there. Therefore, we've got 1 unit that we are working with. It's centimeters, because we're trying to find out, if we're not drawing 30 newtons, what are we drawing? Okay, so this x times the 10 is going to be x, or 10x rather, which is equals to 1 times 30 is going to give you 30 centimeters. Okay, divide that by 10, because you're not looking for 10x, however we're looking for x, therefore divide by 10 on both sides. This is therefore gonna have this 10 cancel that 10, and then we are left out with x is equals to 3 centimeters. Okay, so now we know we need to draw 3 centimeters in a northeasterly direction. Okay, so looking at that diagram that we have over there, remember what the question had said. It said that we need to resolve this into the vertical and also the horizontal component. Meaning, from this original force that is given to us, we need this horizontal and we need this vertical. Okay, so now if we are able then to draw, let's first draw this Cartesian plane using, let's just use this one. Okay, we already know the direction it was given to us, and then we say moving from the center, let's say approximating 1 centimeter, that is. We already know that we need 3 centimeters. 1, 2, 3. And then we are ending in here, okay, in a northeasterly direction. Now, because this one is drawn to scale, any other vector drawn to it, therefore, is going to give us the correct measurements. So that means over here, let's just write it with, if you're having your 1, 2, 3, and therefore it's in proportion to that one, okay? And then, now what you're going to do, you start placing your ruler into the horizontal segment so that you measure what you find in the horizontal. So therefore, this will be therefore Fx, okay? And this one will be for your Fy. If you place your ruler as well in a vertical direction, then it should give you the vertical component as well as the horizontal component, now that the original force has been drawn to scale. Okay, so that is how easy it is to find the horizontal and the vertical component using scale drawing. Everything in it needs to be drawn to scale, so that whatever that you're trying, or whatever vector that you're trying to find out, is able to just be found in scale as well. Okay, so the second one is your resolution of forces into components using calculations. Okay, in this case, we're not using the scale drawing, but we are calculating the vertical as well as the horizontal component. Okay, how? Let's look at the basics that we need to figure out before we get into the calculations. So we need to be able to draw a right angle triangle. So it's called a right angle triangle because it has a 90 degrees angle where the y intercepts the x. Okay, so we use trigonometric ratios to find any side on the right angle triangle. Okay, so we've got 3 sides in the right angle triangle. We've got the one that is intercepting with the horizontal one, and we call it the opposite side. We've got the one on the horizontal side that is called what? The adjacent side. And then we've got the longer side, which we call it a hypotenuse. Okay, so playing around with these trigonometric ratios, therefore, allows us, in fact, to be able to find the vertical and horizontal component. Okay, so that's just why we're saying trigonometric ratios are used to find any side in the right angle triangle, which are then used to determine the vertical and horizontal components of a force that is acting at an angle theta. Okay, so let's look now. There are 3 of them. So by abbreviation, we call them SOHCAHTOA. So with your sign, you've got, write them with red so that it's easy for you to see. Okay, so we say SOHCAH and TOA. Okay, it's just simply a representation of this. This is the opposite over hypotenuse. So that is why it has an O and an H, and then adjacent over hypotenuse, and then opposite over adjacent. Okay, so with your sign, when you want to find the vertical side of your right angle triangle, therefore we use sine theta. Okay, when we want to find the horizontal one, which is on your x-axis, therefore we use what? The cos theta. Okay, and when we want to find the direction, usually we use what? Tan theta, which gives us the bearing, which is a sign, or rather signifies the direction of a vector. Okay, so solution on how to use this Pythagoras theorem. Okay, perpendicular component, or the y component, or rather the vertical component, depending on what you are calling it, but it's one and the same thing. We're talking about the y component. Okay, we call it F perpendicular. It is a force. Why are we saying F perpendicular? It is a force that is perpendicular, okay, to the horizontal. Okay, is equals to the original force, which is your Fr, and then sine of theta. Okay, where else when you want to find the parallel component, or rather the x component, or rather the horizontal component, this all means the same thing. Okay, it is the parallel component, therefore Fr, which is your original force, and then cos of theta. Okay, and then there's a diagrammatic representation to make it simpler for you so that you understand which one is which. So let's look at it nicely. So this is your Fy, which is your F perpendicular, and this is your F parallel, which is your Fx, because it's on the what? It's on the horizontal. Okay, so this is, in other words, your Fx, and this is your what? Your Fy. And these are the components that we are trying to calculate, extrapolating, or from the Fr, which is the force that will be granted to you, so that you are able to resolve it. If Fr into, rather, let's say Fr y, so that it's easier for you to see that it's just a component of the original Fr. Okay, this one as well, to make it Frx. Okay, so let's look now at the resolution of forces into components using the calculations. Okay, so we've got a problem that is given to us on 1.1. It is reading as resolve the resultant force into vertical and horizontal components. So what is given to us is a resultant force of a magnitude of 25 newtons, and it is acting at 30 degrees to the horizontal. Okay, so we've represented the components, the horizontal component as well as the vertical component, using different colors, your vertical component being red and then your horizontal component being blue. Okay, so now if this is given to us as Fr, therefore this one is your Fr y, okay, and this is Frx. Okay, now remember what we have said, that if we want to find the vertical component, the one that is on the y side, okay, we use sine theta. Okay, so we're going to say for finding Fry, which is a component, it is equals to the original force, which is your Fr, and then sine of theta. Then we ask ourselves, what is the original component? It is 25 newtons. Okay, therefore it's going to be 25 sine of 30 degrees. Okay, therefore you punch that into your calculator. You said, okay, what is 25 sine of what? Of 30 degrees. Therefore it is 12,5 newtons. Okay, remember, units are very important. And then with the Frx one, let's use a different pen so that you can be able to differentiate between the two. So the Frx is going to be equals to the original force, okay, which is your resultant force, and then cos of theta. Okay, what is the original resultant force? Okay, that is what, 25, then it is cos of what, of 30 degrees. Okay, so we've used two different trigonometric ratios because they're on different sides as well. So 25 cos of 30 is going to give us 21. Okay, let's write it properly. 21,65 newtons. Okay, that is how simple it is to resolve a force into components using calculations. Okay, now moving right along, my learners, let's now, okay, this was supposed to be a page where we are resolving our components like we did. Fortunately, we did find a spot where it is visible and you can see it in your right angle triangle. That is your FRY and that is your FRX. Okay, and then for you at home, I want you to try this for me. Okay, so number one, it says a force of 1000 Newton acts at 55 degrees to the horizontal axis, and then determine the component of the force using scale drawing. Remember, 1000 Newton is a lot. Okay, that magnitude, it is just too big. So what you need to do is use the scale like they indicated in the question. So say use the scale drawing. Okay, so remember the scale is helping us to enlarge or to reduce. In this case, we want to reduce so that it fits nicely and perfectly in a piece of paper. Okay, so we're given that right angle triangle of that 1000 that is acting to 55 degrees to the horizontal. Okay, then you need to find your FRY and then your FRX as well. Okay, number two, it's saying resolve the following forces into components. So we've got two forces. We've got F1 that is acting 20 degrees to the horizontal, and then we've got F2 of 40 newtons that is acting 45 degrees to the horizontal. Okay, so we need to be able to resolve F1 into F1x. Okay, so this one being our F1x, and then the horizontal one being our F1y. Same thing on this side, you're going to have our F2x, sorry, this is our y, okay, and this is our x. Remember, x is in the horizontal. Okay, let's close this nicely. So this is going to be our F2y. Okay, so with these ones, remember you have F1 as a separate force and then F2 is a separate force in the opposite directions. Okay, so having the direction of 45 degrees to the horizontal and 20 degrees to the horizontal. Okay, so you need in each of them, therefore you need to be able to find the F1y and the F1x, the F2y as well as the F2x. Okay, 2.1.2, you continue to find the component now using calculations. Okay, so you've got your 250 newtons as your resultant force that is acting at 45 degrees to the horizontal. You also have 2.1.3, which is having F1 as well as F2. F1 is at 200 newtons to the horizontal. F2 is at 150 newtons at a right angle over there, going straight downwards into the south. So let's quickly take a recap now of our work on forces by looking at the past question papers. First up, we're going to be looking at the multiple choice questions, okay? That is your MCQ questions revision, taken from different past question papers, your Eastern Cape 2020. The instruction reads as follows. Various options are provided as possible answers to the following questions. Choose the answer and write only a letter A to D next to the question numbers. For example, they've given us an example to say 1.1 to 1.10 in the answer book, and you only write a letter, for example, 1.11, and the correct answer, D. Okay, now let's get into it and analyze how we should approach the multiple choice questions. Okay, so the first one on 1.1, it's saying the bearing of force which is acting in a westerly direction is it A, 0 degrees, B, 90 degrees, C, 180 degrees, or D, 270. Okay, so we need to remember which one is a westerly direction. Okay, westerly direction is on your left. So if you want to remind yourself, what you can be able to do is doing this and say, this is my west, this is my east, and this is my north, and this is my south. Okay, now from this you know that you want a bearing of a westerly direction. That means, remember we had said that when you are working with bearing, you put your protractor into the north, which serves as your reference point. Okay, so if this is my reference point is 0 degrees, and therefore I start reading it clockwise, this will make this easterly direction to be 90 degrees, and this will make south direction to be 180 degrees, and this will make the westerly direction to be what? 270 degrees. So now from this extrapolation, we are able to read and say, okay, so the westerly direction is what? 270 degrees. So the correct answer here is D. Number 1.2, still taken from the Eastern Cape 2020. It says the resultant of two forces acting on an object is 15 newtons. So we're given the resultant force, okay, which is the sum of two or more forces that are acting onto an object, okay. The magnitude and direction of the forces can be one of the following combinations, okay. So now if it's acting worst and worst, that means we'll say 5 plus 20, which will give us 25, okay. B, which is 5 newtons to the east and 20 newtons to the west, could be, okay, because the other one is moving to the right, the other one is moving to the what? To the left, okay. So, and it can never be the north and the west, because that one will create a 90 degrees angle, and it can never be a D, because 5 newtons south and 5 newtons south and 20 newtons west. So here's why we think it is B, okay. So you've got your what? Your 20 newtons west, and then you've got your 5 newtons east, okay. So let's create this. Let's start with the bigger one. Say, okay, let me make this to be longer. This is our 20 newtons, and then it said west, so it needs to point in that direction. By doing head to tail, we are moving slightly from the side to indicate what? This is our 5 newtons to the east, okay. So the resultant is therefore over here. But then how do we then find that this direction? So you said FR plus, is going to be equals to, you take what? You take 20 plus into negative 5. Okay? Therefore, 20 positive times negative is going to give us what? A negative. So 20 minus 5, and therefore it gives us what? 15 newtons. Okay, so thereby we are able to get 15 newtons, which is in a positive direction. Remember, the positive number that we have given to ourselves is 20, meaning moving to the east, or rather, sorry, even moving to the west is what? Positive. So this one is positive, therefore it is west. Okay, why are we saying it is west? Because the western direction was chosen by us to be what? To be positive, since this 20 is made to be what? To be positive. So if our answer that is then positive, then it's moving to the what? To the west. Okay, so that's how we found the answer, or the correct answer, to be B. Okay, this one then, it is extrapolated from the multiple choice question of the National Senior Certificate of 2017 grade 11 paper. Okay, various, still the same instruction, various options are provided as possible answers to the following questions. Write down the correct number, 1.1 to 1.10. Choose then the answer and make a cross over the letter. For example, A to D of your choice in your answer book. Okay, 1.1 is reading as follows: the SI unit for a force. Okay, what are the units that we use to measure force? Okay, is it a ton? Is it a newton? Is it a pound? Or is it a kilogram? That one is very easy. We've been doing it together. The correct answer is B, newton. Then our multiple choice question for NSC 2017 is then saying on 1.2, the y-axis on the Cartesian plane. The y-axis, okay? Let's draw it so that we have a clue of what we're talking about. So this is the Cartesian coordinate system. So I've got the x and the y. X moving to the horizontal, and then y moving into the vertical. Okay, the y-axis on the Cartesian plane represents, is it A, the horizontal component, B, the diagonal component, C, the vertical component, or D, the straight line component? Okay, I know you know this one. It represents the vertical component. Okay, so the correct answer is C. Still continuing on the same paper, NSC 2017 grade 11 1.3 reads as follows: vectors are indicated by a symbol. Okay, which one is correct? Okay, vectors. Remember, vectors are physical quantities that has both magnitude as well as what? As well as direction. Okay, so is it A, F with an arrowhead on top of it, B, V, capital letter V that is, C, capital letter R, or D, capital letter X? Which one has an arrowhead that is pointing somewhere? Okay, the correct answer is therefore A, because now it is giving us what? Direction. This is how we represent the vectors. Then MSCQ, or multiple choice questions rather, NSC 2017 1.4, the longer side of the triangle opposite the right angle, okay, is called the, let's write this triangle with the longer side. Okay, here is your triangle. So it is made up of forces, so that is very important. They are talking about this longer side. Okay, this longer side, we know it as, is it A, opposite, B, adjacent, C, continuous, D, hypotenuse? We know it as what? A hypotenuse side. Remember when we're talking about the right angle triangle and its three sides, where it had the opposite, because this is where the right angle will be. So this is your opposite, this is your adjacent, and this is your hypotenuse. Okay, so the correct answer in this case is your D, which is your hypotenuse. Now, let's look at the long questions. Still looking at the two papers, the Eastern Cape paper 2020, as well as the National Senior Certificate of 2017. Okay, so it says three forces, F1, which is 50 newtons to the east. Okay, let's look at our F1 right over there. And then F2 of 20 newtons to the west. Okay, and then it had F3 of 40 newtons to the north. There's our F3 and it's going to the north. Act on an object as shown in the figure below. Okay, and then they gave us a clear diagrammatical representation. So, alongside with the compass directions. Define the term resultant of two vectors. When we say resultant, what do we mean? Remember, resultant, it is a single vector that has the same effect as two or more vectors that are acting onto an object. Okay, so let's write our solutions over here. Okay, we've already had solutions, so let's just say write a numbering system as it appears. So we have a 2.1 resultant vector is a single vector that has the same effect as two, it could be two or more vectors acting together. Okay, so with that one, remember your definitions are 2 marks or nothing. Okay, so you need to get them right all the time. Okay, identify the two forces that are collinear. Okay, for us to understand what we are trying to find out, so we need to highlight or underline this word collinear. Okay, so in the diagram, so the two forces that are collinear to each other, that are acting parallel to each other, is going to be your F1 as well as your F2. Okay, so moving right along, determine the resultant of 20 and 50 forces. Remember, 20 is a magnitude of what? F2, and then 50 newtons is the magnitude of F1, and they are acting in the opposite directions. Okay, F1 is 50 newtons and it's acting in an easterly direction, while 20 newtons is acting in the westerly direction. So the bigger one is moving to the east. So let's get cracking. So here's your, I'll make it slightly longer. So this is your F, and then it is 50 newtons. Okay, let's check which one is which. It is our F1. So here's our F1, and then our F2 is acting. So let's try and make this one to be our F2, and it has a magnitude of 20 newtons in a western direction. Okay, so now if we have to calculate the resultant, determine the resultant of the two forces. Okay, so what is it that we're going to do? We need to find the sum of these two forces. So it's going to be Fr taking the positive, so it's F1 plus into negative F2. So our F1 is 50 newtons, and we take it as positive direction, and then negative 20. Okay, so 50, that is going to be 50 minus 20, and therefore it's going to be 30 newtons. And because we had taken the easterly direction to be positive, it's going to be in the east. Why? Because our solution is also what? Positive. So now that we are writing it over here, so it's going to be, there you go. This is going to be our FR, which is equals to a positive 30 newtons to the east. Okay, so this was going to the west, and this was going to the east, and then to the west. Okay, so that is how simple we answer that question. Okay, so let's look at 2.4. 2.4, it's saying, hence determine the magnitude and direction of the resultant of all the forces that now are acting onto this object. So now we've already found the horizontal resultant. Okay, that means that we know the collinear vectors as what? As 30 newtons. Okay, now we have the third one, which is your F3, which is what? Your 40 newtons that is acting to the north. Okay, so now if we're finding the magnitude and direction of all the resultant, therefore we have to use a Pythagoras theorem. Okay, let's try to look for a nice space over here. Okay, let's find a space over here. It is fine. So this part, we did find it as our FR. Okay, so it is a signal of what? Of 30 newtons and to the east. Okay, so we're going to combine it with this one. Okay, so that we find, so remember this one is going to be our Y, so that we are able to find FR. Okay, let's say we're going to say FR squared is equals to X squared plus Y squared. In this case, our the horizontal side is our 30 newtons to the east, plus 40 okay, and then you punch that into your calculator. They say, what is your 30 squared? It's going to give you 900 plus into 40 squared, 1600. Therefore, what is then 900 plus 1600 is going to give you 2500. Okay, remember, you're still down with this one because that is what you are trying to find out. Square root of 2500 is going to give you 50. Therefore, our FR, not FR squared, is therefore what? 50 newtons. Okay, remember with your question, it is what? Hence determine the magnitude of and magnitude and direction of the resultant of. For now, what we have found out is the magnitude. Okay, now it's our turn to find the direction. Okay, so how do we find direction? We use the use of the trigonometric ratios. In this case, it's going to be what? 10 theta. Okay, so we can say 10 theta is equals to, remember, with your 10, to remind you, it's tau. Okay, so that means that it's going to be opposite, which is this, your opposite, over what? Over adjacent. So it's going to be 40 divided by a what? A 30. So that theta is equals to, so we say second function, tan, okay, of 40 over 30. Therefore, our theta is going to be 2, okay, then it's 2,95 degrees. Okay, so this bearing therefore gives us the direction. Now on to the last one. If the magnitude of F2, where's our F2? It's this one, which was 20 degrees. Okay, so now if the magnitude of F2 is changed to 50 newtons, okay, so now meaning that it will be equals to the F1 that we have on the side. So if the magnitude of F2 is changed to 50 newton, what is the magnitude and direction of the resultant of all the forces that are acting onto the object? So the magnitude and direction of the resultant of all the forces that are acting here. Yes, if we have a 50 on this side and we have a 50 on that side, it's going to give us what? 0. Okay, so if now we take this 0 to be here, then the magnitude that is there is the only one, it's F3 that is there, which is what? 40 newtons, because it is the only force that is there. Okay, so remember what we're saying is that from here to here, or this second F2 force is therefore now had changed its magnitude from 20 to 50, whereas this F1 was 50. Remember, positive as well as the negative, they're going to cancel each other, giving us a resultant of 0 newtons. Okay, so the only force that now is left is what? Your F3, which is what? Your 40 newtons. So the correct answer for here is that your FR will be equals to 40 newtons, and it's got the direction, okay, 40 newtons to the what? To the north. Okay, so that's how simple it is to resolve this one. Okay, so these are the solutions that we talked about. Hope you understood them, and you will understand them better whenever I give you your own work as well. Okay, so this one is a long question that is taken from NSC of 2017. Remember, we're doing a sum up of the work that we have done so that we can test ourselves looking at the past question papers whether we did understand or not. Okay, so define the term resultant. We've already described it, and we started with it on our prior knowledge. And there's the single vector that has the same effect as two or more vectors that are acting together. Okay, so nothing's changed about that one. And then the 2.2, study the diagram below and provide the labels for part A, for part B, and for part C. Okay, so part A, this is your positive x. Okay, so this is the positive what? X part of your Cartesian coordinate system. And then your x is your reference point, which is what? Your reference point. Okay, in the Cartesian plane, because all the vectors will emerge from it. Okay, and then B, you've got your what? Your positive quadrant. And I'll tell you why we're calling it a positive quadrant, because over there x is positive as well as y. So it is a positive quadrant, whereas this one is your negative gradient. Okay. And then 2.3, calculate the total vector if two forces of 100 newtons and 80 newtons are exerted on the object as shown. So you've got your F1 newtons that is moving into or being pulled in an easterly direction, as well as your F2 that is being pulled in the easterly direction. So both these forces are in the same direction. So what does this say? Okay, so if we have to now find, the question is saying calculate the total vector. So this is your FR. Okay, so for 2.3, your FR has got F1 plus F2. Your F1, let's go slightly back, 100 newtons and 80. Okay, so I've got 100 newtons plus 80 newtons. Okay, I want to signal the fact that the signs are going to be the same because they're going in the same direction. So this is going to be positive 100 plus into positive 80. So because there are no changes in the sign, this is going to give us 180 newtons to the east. Okay. Then 2.4, it goes in saying Sia walks 6 meters in an easterly direction. So the vector A is therefore Sia, because it is moving in the easterly direction. Okay, and then continues to walk 5 meters north. The directions are indicated in the figure below. Okay, so the diagrams are very clear with the directions. So we've got vector A, and then we've got vector B, which is C, are moving to the easterly direction and then moving to the north. Okay, and use the head to tail method to graphically determine of his displacement. Remember, okay, so if now we needed to use or determine the direction of his displacement, therefore we need to use the head to tail, like it is saying in the question. Okay, 6 meters to the easterly and then 5 meters to the north. Okay, we are at 2.4. Even though my ruler is my hand, I want you to know the method. So this is 1, 2, 3, 4, 5, and 6. So we are stopping here. Let's just use this one. Okay, and then this is 6, and then we're saying 6 meters to the easterly direction, 5 meters to the north. Okay. 1, 2, 3, 4, 5. Okay, so we stop right there as 1, 2, 3, 4, and then 5. Okay, to make this to be black as well. Okay, so now we had to find, because now you're using the head to tail method, I want you to see this, the head of this one is therefore joined by the tail of this one. Okay, so that is why we call it a head to tail method. Okay, so displacement, we need to find this side from the starting to the ending. Okay, so you can measure this using your ruler to find the magnitude of the displacement. Okay, let's find out if we did yes. Moving right along on your 2.5, a worker is using a ladder to fix a light bulb on the wall. The top of the ladder is resting against the wall at a point of 4 meters above to the ground. The base of the ladder is 1 meter away from the bottom. Okay, they've indicated nicely for you on the horizontal that is where the ladder is, that is where the wall is. Okay, so it is placed at a certain angle over there. And then the base of the ladder is 1 meter away from the bottom of the wall as shown in the figure below. Then our question then goes to say, calculate the length of the ladder. Okay, how long is the ladder? Okay, remember this is the ladder that we're talking about that the man is stepping on. Okay, so now because we are aware of the y and we are aware of the x side, we can easily find the length of the ladder by looking at it. We can even use the Pythagoras theorem. Okay, so we've got 4 in your y and 1 in your x's, and we're looking for FR. So I'll say for you, use Pythagoras theorem. Okay, let's use that. Let's put it into practice. We say we want to know FR. Therefore, it's going to be FR squared x squared plus y squared. Okay, so the x1 is 1 squared plus into 4 squared. Therefore, you put this in your calculator. 1 is therefore your 1 squared, and then it's giving you 1. What is therefore 4 squared is going to give you 16, and therefore the 1 plus 16 is going to give you 17. Therefore, you still continue carrying this one out or carrying it down because you're not looking for r squared, but you're looking for FR. And then when you reach into this place, you just say, okay, that square root is cancelled by the square in there, so you're left with your FR, which is therefore your square root of 17, which is giving you a what? A 4,12 newtons. Okay, in that way we have found, look what we have found. We have found the length of this ladder, which is what? 4,12. Because we're talking in terms of a physical quantity of a distance, then it's 1,2 meters. Okay, that is how simple it is. So mind you, these are the past question papers which you guys can use anytime, so that after learning all the chapters that we've done so far on mechanics, you are able to test your understanding. How far is your understanding? How you are able to attempt different questions, and the different methods that you can use that are simple, so that you will find answers quicker. Okay. So this is the solution that we were looking at, and how to find the resultant force. In this case, the resultant force was our ladder. Okay. So I want to end today's lesson by a quote by Colin Powell. It says, there is no secret to success. It is the result of preparation, hard work, and learning from your failures. Okay, I hope this one inspires you to continue working, even though you're not getting it right the first time or the second time, but rest assured, eventually you will get it right. Okay, I thank you.